one thing. It's never just perspective. It's always a combination of how we see over distance and how something that's getting further away from you appears to you in your visual spectrum, which would be limited.
I know, but you kept saying the atmosphere gets thicker the closer to the horizon. So, but we see the same effects at a mountain that's higher than the horizon, and even like a building. If you're downtown, you see the sun, quote unquote, set behind a building. What's the difference between those three settings?
Well, you can go on the other side of the mountain. You can't go on the other side of the density layer that you're looking for. That
I
atmosphere
can have
became more
somebody on the
dense.
other side of the horizon. I can have
The
somebody on the other
atmosphere
side of the
you're looking
horizon
through
still see the
became
sun.
more dense because you put a mountain in between you.
Correct.
The
So I
mountain is
can have,
more dense
hold
than
on.
the air.
I understand your point. So I can have somebody on the other side of the building, on the other side of the mountain, and on the other side of the horizon still see the sun while it's setting for me.
Flat plane, if someone's closer to the sun, i.e., a different position than you are after you've set, they're going to see the sun. Yeah, because it's less dense. They're
Okay.
looking through
So
less dense of a layer
that's
of
why I'm
atmosphere.
asking that's why I'm asking the question, what do you think the difference is between those types of setting? The one behind a building, the one behind a mountain, and then the one quote unquote behind the horizon. What's the difference between those three?
Think there's much of a difference because I have proof that like the sun can project itself. There's a bridge where I film often in Grand Isle, Louisiana. That's about 400 yards from where I film a lot of times. And in the wintertime, the sun sets under that bridge. And often the effects, depending on the conditions of the day, will make the sun appear to be in front of that bridge, which I know it's not, right? It's only
Yeah, that's
400
glare.
yards away.
That's called glare.
Right, but I mean that's the appearance. That's how we see. We see glare. Those effects don't always happen.
Yeah, we
It's
can we
not
can
every
account for that. We
sunset
can
that.
account for that with a solar lens, a filter. Sorry, solar filter. We
I
can
was
account for
just
that.
making my point as you cut me off again that how we see prospectively and with glare. Thanks for adding another thing that affects what we see. I
And
mean, it
account
is
for
amazing. Yeah.
it. Yep. And account for it. Yep.
Yeah, we can account for all the other stuff too. It's when you start
Yep. I
avoiding those
agree.
things
I
like
agree 100%.
perspective. Yeah, it's when you take out perspective and say the sun sets because you're spinning away from it due to Earth curve, right? Is when you run into problems and get stuck in a dogma where you can't see it any other
No,
way.
it's much easier than that. It sets
I think it's
because of
way,
because it's
way, way
blocked.
easier. I agree
Yeah,
with Wesley.
it's because it's being blocked. That's why. You can
I,
talk about spinning, that's fine. You can convolute it with that, but it's just because behind the building it's being blocked, behind the mountain it's being blocked, and
Okay, I agree.
behind
I
the
agree.
horizon, hold on, being blocked.
I agree.
Okay,
But I
thank you.
just think it's on a flat plane, not on a spherical. I don't think the blockage can ever be physical Earth curve. You do.
But it can be a physical mountain and a building, just not Earth curve.
Absolutely. And if we
Okay,
lived on a
cool.
sphere, it could be physical Earth curve also. That's the part I don't like. I think there's other ways for it to set. And there's other ways it would set and can be proven to set on a flat plane. Light set as they move away from you on a flat plane.
well,
So the
I mean,
sun
that's a
being
claim, but
light,
you have to explain how or why. That you got. I mean,
you don't know how or why something go away from you appears to go lower, and as it gets further away, you look into a more dense atmosphere. So it would appear a set or blink out in some instances,
Man,
just
take a
like the
breath,
sun
bro.
does. And I
I mean,
can't
more.
help you,
Well,
bro.
your claim is more than perspective. Like it has to be like 25
Of course
degrees
it is.
more than perspective. So no,
Yeah,
I
I was
don't. I'm
the
not aware
same
of
guy
anything that
that.
does that.
Yeah, I was the same guy that just said it's way more than perspective. You remember that about 5 minutes ago?
I think that's probably me.
No, that was me
Like,
saying when he said, I just think it says due to perspective. And I said, no, I've never said
oh, it's
that.
more
It's
than that. Yeah.
always multiple factors. Yeah, thank you. I'm glad we
The
agree
sinking
in the beginning, bro.
refraction. I posted at 15 after the hour. This is Las Vegas, so Las Vegas is a good candidate for doing these sorts of tests because it has typically a very stable temperature gradient. This right here, you are not going to have sinking refraction. So we could go to Vegas, see if things disappear bottom up, and eliminate sinking refraction as a as one of those potential many sources that make things disappear bottom up.
Cool. We can go to Vegas and measure Earth curve then, because we know it's not any type of refractive effects, right? So no refraction in Vegas, no sinking refraction, so we can easily measure Earth curve there, right?
Right now, that's from like this.
Yeah,
What I just
I'll
posted
take
is
that
from what I post right now is. I think this is the midnight one that they send up.
Okay, well, would you be willing to? I'll fund any test that you do that's a measurement for establishing a horizontal plane over a static lake, which Vegas has, right? And measuring down to the water and proving that the water curves down from the original benchmark away from it at a curvature rate, any curvature rate, not even the 8 inches per mile square, but any.
Well, my position is I appreciate it. I would say as long as we can do it, like get up 20 feet off the water, because when you're at the water, that's one of the worst places to do this sort of thing, unless we're not using any lasers or anything.
So
but if we're using lasers, you don't want to be right off the water.
So you think Soundly's power lines and bridge is bullshit? I do too. We agree again, bro. That's 3 or 4 things we agree upon. Can't do it low level across water. Yeah, the worst place. Plus a place that has like hundreds and hundreds of refineries around putting out all this dust particles and whatever they put out. An airport, 4 highways, 2 trains, multiple boats. Yeah, I agree. It's the worst place ever to do long distance observations.
With the laser.
Nevertheless, people will
with the
cite
laser.
Soundly's. Yeah, lasers are effective, I believe, too, but I don't use them that often. But anyway, so you're saying you can take a laser over Lake Pontchartrain and it wouldn't curve?
No, I'm saying if you're gonna do like you kind of pivoted to this, like doing things over water. My whole point was just in Vegas, we're not seeing conditions that would produce sinking refraction. So that's one of the things we can eliminate and do some observations.
I pivoted away from observations and went directly to a first order measurement, which would be
we're talking about
hang on.
We're talking about bottom up obstruction. Everybody was here.
Hang on. Yeah, we're talking about bottom up obstruction, but we're talking about water curving causing the bottom up obstruction. And a way to do it that you claim that can be done in Las Vegas, because you rule out sinking refraction because of the conditions, is to establish a horizontal plane above a static piece of water and measure down to the water. It has nothing to do with refraction. Nothing, because you're not doing long distance, one-shot measurements.
Where do you find static water?
As static as it's not going to cause you to wipe out 6 feet over 3 miles. Meaning there's not a 6-foot wave, there's not 6-foot tides, there's not a wind blowing in one direction that causes a 6-foot bulge of water on one shoreline and not on the other. Which, oh, by the way, happened. Not 6 feet, but.
Lots of tsunamis in these pictures that we're posting over water.
No, we're talking about like on Lake Pontchartrain, you can measure one shoreline height of the water and it might be 2 or 3 inches higher than the opposite shoreline, and it's due to the way the wind is blowing. So it pushes the water up against the northern shore and draws the water away from the southern shore. So you're going to get an angle of water without flow, which is hard to do, by the way. But if the wind is constant, it has that constant push. It will create a slope of water. Not a curve, but a slope, rise over rain. But I am glad we have.
How would you set your horizontal?
I would set an original from a benchmark, an original horizontal line, and then extend the straight line segment, which is a method used by surveyors all the time.
Yeah, I'm asking you, how do you set the initial horizontal?
You can use a multitude of instruments that are highly precise. You can do it 100 feet, 200 feet, 300 feet, 400 feet, like really accurate.
Do you know how they set the horizontal?
Yeah, I do it every day for a living.
Okay, how do they do it?
You create a benchmark. If you want to be 1 foot above the water, you set your instrument up to be 1 foot above, like the story pole, whatever you're using. You can measure that you're 1 foot above the water, and then you can extend that straight line from that point in any direction. And if you're just using the instrument to extend the straight line segment that you created initially, you can do it infinitely in any direction.
Yeah, I'm asking you, how do you create the initial horizontal? How do you know it's horizontal?
That's what the machine is designed to do by Globers.
What
Is to
machine?
establish
Yeah,
a
I'm
horizontal.
sorry. What machine?
Lasers, theodolites, auto levels,
Okay. Do you know how?
water-based levels.
Yep. Do you know how they set the level? The horizontal.
Do I know how?
Yeah. Do you know
Yeah,
how?
gravity. If it's locally level at that gravity point, but is that
Okay.
your point? So you know that, but you don't know what an auto level is?
Yes, I do. I was getting to the point of how they set. I
You
just
were just
wondered.
trying to see if I did. Pretty
Yeah,
sneaky, right?
correct. No, I was
Yeah.
just wondering if you knew that. So I didn't know you
Of
believed in
course I did.
gravity. Hey, dude, I'm serious. I'm just being honest. I didn't know you believed in gravity. That's kind of interesting to me.
Well, I believe that's the case that they say that you were going to say. I don't believe in gravity as you know it, but the direction of down is definitely established, and that's what the auto level or like a liquid base level, like a carpenter's level, is going to use what you would call gravity to establish that local point being horizontal.
I agree. No, that's good.
I'm fine with that. But no matter how you set the initial one, you can use a straight edge from that point to extend it out. You don't have to, because the argument is every time you move your instrument, it resets up to the gravity point that is on a curved surface, which is what you're trying to measure in the first place. And the point is by Globers is that there's no way possible to use these highly engineered tools in a method called planar surveying to create a horizontal line to measure the curvature of the Earth at 8 inches per mile square, which is ludicrous.
Okay.
Globers aren't smart enough to come up with a machine that can establish a horizontal line 1 mile. That's crazy.
How would you do it?
I would leapfrog. I would.
He basically
every time
did it. He set up posts over water, used a
yeah,
laser. He used a
So
laser
water-
to sight from the prior to post
With-
to place
lots of
the
air.
next post.
I'm serious. I'm just being honest. I didn't know you believed in gravity. That's kind of interesting to me.
Well, I believe that's the case that they say that you were going to say. I don't believe in gravity as you know it, but the direction of down is definitely established, and that's what the auto level or like a liquid base level, like a carpenter's level, is going to use what you would call gravity to establish that local point being horizontal.
I agree. No, that's good.
I'm fine with that. But no matter how you set the initial one, you can use a straight edge from that point to extend it out. You don't have to, because the argument is every time you move your instrument, it resets up to the gravity point that is on a curved surface, which is what you're trying to measure in the first place. And the point is by Globers is that there's no way possible to use these highly engineered tools in a method called planar surveying to create a horizontal line to measure the curvature of the Earth at 8 inches per mile square, which is ludicrous.
Okay.
Globers aren't smart enough to come up with a machine that can establish a horizontal line 1 mile. That's crazy.
How would you do it?
I would leapfrog. I would.
He basically
every time
did it. He set up posts over water, used a
yeah,
laser. He used a
So
laser
water-
to sight from the prior to post
With-
to place
lots of
the
air.
next post.
With lots
leapfrog
of compounding
basically,
air.
or extending the straight line segment is every time you move your equipment, no matter where you set up, or if you come back a year later and set up in a different spot, you would reestablish your horizontal by shooting the other points that are horizontal. And if the measurements are the same, that means you can extend that straight line segment out. And in Louisiana, I wouldn't do it any more than 200 or 300 feet. Over water, I wouldn't do it more than 200 feet.
Right.
Over stable conditions, like in the wintertime, we go up to 400 or 500 feet.
Right. Which you wouldn't notice the amount of drop due to earth curve in those types
Well, there
of.
wouldn't be drop in that instance because it's a plus or minus. It would never be like, if you would notice, it would read on the instrument. If it's not, then you're never going to mark it. You're always going to mark the same horizontal plane. If you're now going to say it's impossible to move an instrument and reestablish the horizontal, and extend it, then you're stating what I said earlier, that you think it's impossible to establish a 1 mile long horizontal line, which I think
I
is
think
with
calling by the way, I think calling it horizontal
those
is confusing.
tools. Yeah, with
no
those tools,
horizontal is not confusing, not in
yeah,
surveying.
with those tools, it
No,
would be
for
impossible.
Globers, I think a better term would just be extending the original
Straight line
horizontal.
Forcing
Yeah,
the
straight line segment.
Yep.
Yeah, forcing the line.
It's called a straight line segment because it doesn't curve, it doesn't angle. It's straight,
How straight?
horizontal to the
How straight?
benchmark.
How straight?
Straight enough to measure 8 inches.
Yeah, but nobody. You just said you run it a couple hundred feet.
Okay, let me put it to you this way.
No,
You
answer
wanna
my
fund it.
question. Answer my question. Don't run away from it. I
I'm
want
not
to engage
running
with
away,
you
bro.
honestly
You don't
on
have
it.
to go by your script. I don't run away. I've been here 10 years. I've never run away once from any
You're doing
question.
it right now, though.
Well,
Just stay
state
with
your
your
question
script.
again.
Okay, fine. Go ahead, run.
No, state your question again, and I'll answer it. I don't even think you know what
Okay,
your question was.
so you would realize that you can't detect with your instruments. You can't detect. You can't make a line straight enough over 400 feet to be able to determine if it's earth curve or not.
I don't believe that at all. I believe it's very easy to do.
Okay,
I think I can make a
what
very
is
accurate.
what is the earth curve over 400 feet?
There is none.
I know at 200, it's like a couple millimeters. No, it's like
Yeah.
a tenth of a millimeter, half a
Yeah, and
millimeter.
what's the error margin for your levels?
I'll refer you to what's his name? He comes in here all the time. Rob. I'll refer you
Well,
to
it's
Rob
not just
on
that. It would be it would be the error of the laser using to sight it, and then whatever he's using to drive the stakes in. He'd have to make sure that like every stake would have to be driven within
Well, yeah,
that tolerance.
I'm just starting with the initial level that he's using. They all have error margins on it, so
Yeah, but the error margins would be plus and minus. They wouldn't be in a downward direction below the original benchmark, which would ultimately, if you went far enough, double back on itself and come back to the start around the sphere. That's ridiculous.
I had this conversation with him the other day, Wesley. It was so weird because it's like he was arguing that it's okay to use instruments that are outside of the margin of error as long as it's plus or minus because it like somehow averages out.
I know.
Which seems weird to me, but
yeah, it's never going to be in a downward unless your error margin is in a downward direction and matches the 8 inches per mile square, which it would never do. You would never have an error that big unless you're just incompetent.
So you think over 400 yards, you can do a perfectly level line with less than a millimeter tolerance?
No. Well, lesser is always going to be plus or minus.
You think your tools will allow you to get less than a millimeter change over 400 yards?
Yeah, they say
it's
they
400
can, but
feet,
I think
half of a millimeter.
Oh, 400 feet. What? Oh, you said they say they do. What is their tolerance? You said they say they do.
depends on the instrument, but I think their book values are in a vacuum setting, which we're never in a vacuum setting. So I would say even the claim that you can is wrong, but you can sure as hell do it enough with the plus or minus. That's going to happen with human error,
You said
tool
it
error.
again. You said it again.
I don't know why you just cut me off to say he's doing it again.
I know, because you said it again. The
And
plus or
that
minus.
excited voice is a tell, by the way.
Do you think your first one is down like minus and the next one will be plus so it cancels out?
It can be.
Well, I know it can be, but you think you're that precise. So now you're precise enough to measure. I'm going to do it all the way to the error to the minus. Now I'm going to do it all the way to the error to the plus. Like, that's not how you do that, right?
I don't think you even get. Have you ever in your life use a theodolite?
A theodolite, yes.
Okay. Did you have plus and minus error margins in your measurements if you did multiple?
Yeah, I only did one, but yes, you have any. Hold on a second. Any measurement. Hold on a second. Hold on a second. Any measurement has tolerances and plus and minus.
Okay, I agree.
Okay, so what was the point of your question?
The point is, you laughed at me saying that the plus and minus averages would never equate to a sphere. And now you're saying you yourself have used these tools and know that you would have, if you did it, which I don't believe you have now, you would have plus and minus error margins. Yeah, I agree with you.
Any measurements
Never.
we take have plus or minus error margins. That's why if
I
you
agree.
get a measure, hold on a second. If you get anything within that margin, you cannot be sure within that plus or minus where you were at. That's the whole point of precision. Like you should know this if you measure things, right?
Now, this is entertainment because when you personally set up that theodolite that you used and you had an error margin, what was it?
I don't remember. It was 10 years ago.
Yeah, you don't know because you don't know your error margin. That's the whole point.
That's what you're saying. You do it and you don't know the error margin. I've done it one
You
time.
don't. It's an error margin. It's called an error margin because it's factored in as an error margin, but you don't know. You think you're taking the accurate measurement, but knowingly, because you're a human and that you have a tool that's not perfect or may not be calibrated perfect, that you're going to have errors. Always plus and minus, never in one direction is really
You don't know that. You don't know that.
Oh, well, I'm being told that.
By who?
I'm,
Don't listen to
by
them
the
anymore. Please.
by who? By the surveyors and by the experts that design these
No,
tools, and
nobody
by
has ever
common
said
sense.
trust the measurement that's within the plus or minus range. Nobody's ever
By the
told
way,
you that.
I looked this
I
up.
never
A
said
five
that.
arc second, so 5 arc second error over 400 feet is 2.95 millimeters. So it's an entire order of magnitude error on top of what you're
In which
needing.
direction? In which direction?
Wait, if somebody came to you and said, "I'm going to use a tool," and the margin of error is
Direction, sir.
it doesn't matter. If somebody came and said, "I'm going to use a
Okay.
tool," okay, hold on, it's plus or minus. Now I have a question for you. If someone came to you in construction and said, "I'm going to use a tool," and the margin of error is an order of magnitude off from what you demand of me, what would you say to them?
I'll do the best I can, but over distance is the key because we're not measuring just the 400 feet. We're taking the plus and minus error margins that we know are in there, even though there might be under that distance the degree that wouldn't give you an accurate measurement. But if you take that plus or minus error and go a mile with the same instrument, and the drop rate from horizontal is supposed to be, let's say, 2 inches, then unless you made all these errors, which you know more than I do about that piece of equipment you just looked up on Google, because some of them are more accurate than that, I would be willing to bet, because that seems pretty high.
Well, what was the one that you used?
All
What was the
have to
error on
be
that?
they would all have to be in the downward direction.
Well, okay, what's the let's look at what's the cumulative error of this over 2.7 miles?
20 feet. It's nothing, bro. It's minuscule. It's like
Every time you take another
6
measurement,
inches or something. It's supposed to be
every
6 feet of drop, and the error margin, which is, oh, by the way, plus and minus again, is less than a foot. It's like 6 inches, if I remember. This was like 5 6 years ago.
every time you take another measurement, you're compounding it, so you have to square the error every time you take
Yeah,
another
you
measurement.
do not. You're not compounding errors. No, you do not. That is not how. You're just making shit up now.
No, I don't think he is.
No, I'm an engineer.
Yeah,
I
he
do this
is.
every day. Like I don't know what you're talking about. But when you double the measurement, you square the error.
No.
Okay.
If you did, we would be constantly off. Like
Yes,
constantly way off.
that is 100% correct when you have to get the tolerance.
That's just not right, bro. I
So
mean,
what kind
that's
of
comical. It's
what
not
kind of
right.
what would you do that for? Like an example where you would do that for? Could you give an example? Are you talking about surveying or
Yeah,
what
I
type
mean
of-
when he says he does I think you called it piggyback or whatever it is where you take one measurement
You don't even
from
know
one
it,
post
bro.
and then you go you keep doing it. When you go what'd you call it?
I'm not going
backside?
to tell you, bro, because if you're going to act like you're an expert in this or know anything about it, and you don't even know the methods used, I have trouble wasting my
So
time.
we talked about this before when you set up a wall, right? We were doing set up a wall, make it flat, but then put the wall up. But in between each wall, you're going to have some flexibility. And every time you have another wall, you're not doubling the air, you're actually squaring the air, the tolerance or the air in that case. Just like per mile squared, right? It's the same type of thing. So yes, your measurement is only good for one measurement. Once you take a second one, you're compounding on it.
Oh, okay, let's just move on. I'll give you that. Okay, it compounds, it doubles. Does it double in the same direction?
Yes,
No, it doubles in both.
It goes. Hold on a second. It does square in the negative direction, and it squares in the positive direction.
So every time you make a horizontal and you extend it, you're completing one section of a sphere.
So again, you're
You
thinking
do the
about
same
hold on a
distance
second.
measurement
You
every
ask me a
time
question,
you
and then you
create a
can't stop
sphere.
talking. What?
I
Hold on
can't
a
quit
second.
talking. I just think it's hilarious.
And you're not the actual what you're building is not doing it, but your tolerance is squaring every time.
Okay, and I'll state it again. So now your statement is if you do the same 400 feet over and over and over again, extend it and have the same error compounding, you're going to complete a sphere over time?
Eventually you could, depending on the tolerance, but
There you go.
you're never gonna hold on a second. You're squaring the tolerance, which means you can't be as sure the second time you do it as you were the first time. The third time you can't be as sure again. You could end up somewhere between the square of the negative and the square of the positive. You will likely end up more toward the middle, but you don't know. That's the whole point of tolerance.
Yeah, I said that a while ago. You didn't even know that you had an error. It's just a built-in tolerance. But
That's my whole point.
Hello.
You don't know. You can't be certain.
You're interrupting me. But what you do know is that it's never a compounding error in one direction that would make a sphere.
You don't know that. That's the whole point. You don't know.
Okay, so fine. So your final conclusion here is that it's impossible to make a horizontal line.
A perfectly horizontal line, yes.
No, extend a horizontal line well enough to notice an 8 inches drop over per mile square.
With the tools we're talking about, you
Be careful here.
Hold on a second. Reciprocal zenith angles basically
What
do
the
this.
hell are you doing, bro? We're not talking about reciprocal zoom angles.
Okay. Well, then with what you're talking about, no. Forcing a straight line, no, you can't.
So here we go again. I want to say for the audience, another person, no matter what his view or beliefs are, thinks that the tools that we have in 2026 are incapable.
Your tools.
Any tool on earth engineered to create horizontals. Yeah, bro. I don't know why you're interrupting. I'm going to conclude one way or another.
Because you're strong.
I'm not even talking to you. I'm not even talking to you, so I can't be strong
about me. You're talking about
I'm not talking about you. I'm saying that here's another person, right? Whoever he is, not specifically, another, and it seems to be like a repetitive thing once we get down to it because it sounds so ridiculous. In 2026, it's impossible to take a tool that's designed to extend a straight line segment, a horizontal line to make a horizontal plane, which is a surveying method. It's impossible to do that over enough distance, accurate enough to measure 8 inches per mile square. Ladies and gentlemen, it's impossible to measure the drop.
That's incorrect, but
with these tools,
with that method, with the method that he's describing.
Yeah.
I mean,
so
there's a reason why surveyors don't do it the way you're describing.
Oh, really? How do surveyors measure curved water, sir? Please explain.
No, I'm just saying if surveyors have to go out and measure things over long distances, like they're building a road or whatever, they don't go out and set up 200-foot segments and then like reshoot with lasers. They don't do that.
Total stations. They use total stations and GPS.
Really? Yeah. Now they use GPS almost always. Yeah. In 2026.
Yep.
Yeah.
So,
sure do.
So yeah, your point.
Can you establish
that's what the pros think that the GPS gives the most reliable, consistent results.
I'm all for it. What unit are they using that's going to? So you're saying it is possible to establish a horizontal line over a mile, accurate enough to measure earth curve, because surveyors are doing it now with GPS, right?
Sure. Yep.
Yeah. Okay.
That's what
Research that model.
that's what LIGO is. You got it. Good job, man.
So good job, man. LIGO, you just go into the script, but you do realize.
No, that's a perfect example of a straight, as straight a line as we can get over that
And
distance.
they use GPS. They use GPS to make LIGO. I'll take that bet.
Yep. Total.
I'll take that bet.
Okay, I could send you. Jesse of Path of Light has the blueprints that show it.
They don't show that they use GPS or they use
They set up monuments and they use total stations with GPS, and you can actually see the elevation go up and then go down in the middle and then go back up, or sorry, the vice versa of that. So it's a straight path, but that you keep interrupting. It's a straight path, but the GPS, the elevation actually changes, which is kind of weird.
My claim is they didn't use GPS to do that. They used theodolites. Now, what's your claim?
They use total stations with. Okay, you ask me a question and then you keep going. It's weird. So they use GPS. They use GPS and total stations. Yes.
An AI, which could be wrong, says the LIGO used high precision dual frequency differential GPS and high-end surveying equipment, including total stations, to align its 4-kilometer vacuum beam tubes to within millimeters.
How much did you bet me? How much did you bet me?
Well, which one?
What do you mean, which one?
You know there's two, right?
Two what?
LIGOs. Damn, you're ignorant about everything, bro.
It doesn't matter. Either one.
So both of them used it?
Yep.
I live 10 miles from one of them.
Okay.
LIGO Livingston.
So you know exactly how it was built then. So what'd they use?
They didn't use GPS. I know Turner Industries was one of the surveyors that went out there. I've talked to 3 different engineers that work in the office. I've been to it multiple times. No, it's not stories. I have pictures. I have videos.
Okay.
Not a story. You know, on the tube of LIGO that they have graffiti, they have stickers and graffiti. You know, they just put a third tube inside one of the other tubes. I don't know which leg. I could look it up, but
cool story. What is that? What is the point of this?
You know why they did that? To pick up more black hole interference further out.
This is a total non sequitur. It's a total non sequitur, and it's weird that you're doing it again.
It's weird that you try and tell me something that you know about something that I know a lot about, bro. Like more than you ever thought.
Was there a contention that they used GPS? My understanding is that they did use GPS.
Yep.
Was that? I just kind of was only partly listening.
Yeah. It's fine. It's okay to be wrong.
They claim they do.
Yeah. 100%.
Was Raqia saying they use GPS, or was he saying they don't use GPS?
No. He said they didn't, and he wanted to bet me on it. And then stupid Finky came in and ruined it by showing that it was. But
I found an actual source published that details the construction for both sites.
Yep.
And I haven't read through the whole thing, but we'll get to the bottom of this.
Yeah, and it's not about a gotcha. It is just about, hey, they use GPS to do as straight a line as we can do nowadays, and they didn't do whatever the force the line that we were talking about before, the leapfrogging. So
post which model they use, so I can go get one and make a horizontal line over static water and become a glober again. Should be easy, right?
Yep, total station.
I have a total station.
Okay, then you can do it. You just have to set different markers and put your total station down as you go along the mile or quarter mile, whatever you want to do. That's how.
So it's been done.
Yep.
Can you post that?
He just did.
No, can you post that being done? Surely someone videoed it.
Oh, now we're moving the goalposts. Everybody noticed that, right?
Oh, no, we're not. I just want to see it.
It's not true, and it's not. Well, then why do you need video?
Well, video would prove the claim.
Oh, okay. So you are moving the goalposts. Okay.
That a total station can accurately make a horizontal. Because a while ago you said it wasn't possible to be done.
Nope, with your method. In the tolerance of the Earth curve.
But with a
who
total
we were
station,
talking
that
about.
tolerance can be met. I can make a horizontal line with a total station that then I can measure down from the top of those stakes that the total station made sure were perfectly in line, a horizontal plane with the
Okay,
original
document
benchmark.
how you did it. Document how you did it, and tell us how it's different than LIGO.
I didn't finish, right? So I can use a total station tomorrow. I did it wrong 10 years ago. That's out, right? But tomorrow I can go use a total station, do the same method, drive in a stake a foot and a half above the water, use a total station to get the top of the stake, the same horizontal plane for a mile, 2.7 miles, and get a drop rate according to the curve, 8 inches per mile square, 6
Yep.
feet.
Yep, and you're not going to be able to do it with one total station shot. You're going
Well,
to
that
have to
would
keep
be
moving it. What?
Well, that was easy. I mean, I've been asking for this for years, right?
Well, you could have looked up how LIGO did it then. You got a buddy that works there. Why didn't you do that?
You think I have it? I
Well,
mean,
apparently not, because you're being surprised at us suggesting it now.
well, you're the first person in 10 years that's ever agreed that you can do that.
You should go talk to LIGO. LIGO did it. Well, this
Don't
shouldn't
worry
be a
about what
shock
I'm
to you.
going to do. Just worry about that's fine. So it should
Okay.
be all over the place, right? Surely someone other than that one group at LIGO did it, right? Surely some Glober to close this argument down has done this and videoed it and posted it. Surely.
Oh, did you video the first one that you did?
Yes.
Where is it? Post it, please.
Don't worry about that. I posted it before I have it.
Okay, post it. That's what I'm asking. Just
I'm
tag me when you
asking
post it.
you, just think about this, right? Surely if a Glober could rub it in
Wait,
our
hold on a
face,
second. You're running away again. You
I'm
asked
not
me
running
you
away.
asked me for a video of LIGO, but when I ask you, you don't want to give it. It's weird.
It is weird that you don't have anybody that's ever done it besides me
Yeah.
and LIGO.
LIGO.
But you don't
I
have any Glober that would shut this argument down by doing it.
why isn't LIGO good enough?
You understand what I'm saying, right? You don't have video of that either.
Hold on a second. Why isn't LIGO good enough?
Well, I'd say it would be if they had video. You just post it right now.
Why?
I'd like to see the video of LIGO doing it and how they did it.
But you won't post your video of you doing it.
No, I'm not posting it. No, you're right.
Okay. Dual standard of evidence. Thank you.
Not really. I just want
Okay.
like someone.
That's fine. Now you
Not
know.
really.
Now you know, and you can go research it. That's fine. That's all. We learned
Yeah,
something.
I'll go read. I can't. I'll do it.
Yeah, no,
The
I know
paper.
you will. I'm not. I
All right,
won't
the
doubt
paper
that.
I posted earlier was titled basically how it's titled Precision Alignment of the LIGO 4-kilometer arms using dual frequency differential GPS. I posted figure 9C, which is literally the GPS readings for the Livingston site.
Good deal. But you agree too, Finky, that I can take that same unit and go establish a horizontal line over 4 miles because LIGO is 4 miles, right? Or 4 kilometers or whatever it is.
Yeah, it seems like it.
And what's the drop rate of 4 kilometers? Can you figure that out for me?
It's 2 miles, so 8 times 8, it's like 2.5 miles. So 8 times 8, 64 inches.
64 inches. I should have from my original benchmark. Let's say I do it at 12 inches. At the 2 mile, 2.5 mile, or whatever it is, close to that probably. I'm doing it in my head. Whatever it is, over 2 miles, I should have 76 inches of drop. Yep.
4
There you
kilometers
go.
is
All right.
4.1 feet.
That's easy. And I only got to go 2 miles.
Yep. Only
That's
2
crazy,
miles.
bro. Seems like that would be done over and over again. And this seems like every Glober in the world would be showing this.
That's why we appealed to LIGO. It's weird.
No. Forget about, say LIGO never existed and this debate did, right? Every Glober that had access or would love to fund this and show that all flat earthers are ignorant would have video after video of this being done, right?
Oh no, because we've done that
They
with
wouldn't?
outer space. We've done that with outer space, and you guys just say it's fake. So,
Did you really
and
just
we
go
did
to
that with Antarctica, and it was claimed it was fake. So
I
no,
don't claim
that's what
Antarctica
happened.
is fake. You're just lying now. I think the 24-hour sun exists in Antarctica.
Oh yeah, many don't though.
I'm not moving
That's
to that.
good on
But
you.
anyway,
Good
so
on
it's
you for
not
believing
all
that. Good
flat
on you
earthers.
for
But anyway,
believing that footage, but
So
not
you're
the
agreeing there's
face.
no Glober out there that's ever used this instrument or any instrument like it to do this horizontal plane thing?
No, LIGO did.
No, besides LIGO. You're agreeing.
No, I don't know if anybody else did. One or two is good enough for me.
Okay, but you know the video would be posted right now, right? You'd be able to get it.
You would watch LIGO the
I'm not talking about
surveyors.
LIGO.
Hold on a second. You'd watch LIGO being set up with surveyors. You'd watch that footage for hours on
Absolutely.
end.
Absolutely, yeah, 100%.
Okay, that's cool.
But it's not over water, so it's not basing it's not what I'm asking for anyway, but I would still watch it. But surely
Oh, so
eggshells or
that's not good
someone,
enough. Now it needs to be over water. Got it. Okay.
well, that's what we were talking about, water curving. Curving water, drop of the water from a horizontal plane.
Or Earth. Or Earth.
Well,
I
Earth
mean,
goes up and down. Earth, I can build a 8-inch per mile square out of sand any day. I'm not sure what you're
what
laughing
does
about.
that even mean? I can build 8 inches per mile squared out of sand. What does that mean?
I can take a benchmark of Earth starting at any point on Earth and grade it to an 8 inches per mile curvature rate.
Oh, Jesse's here. Oh no, Jesse's not in chat, is he? Yeah, he's in chat.
Did you hear what I just said?
No, say it one more time because I saw Jesse's name pop up. Go ahead.
I can take any of the above mentioned instruments, anyone that I own that you would say, anything that establishes a horizontal plane, and take any benchmark that you give me and grade the Earth to follow an 8 inches per mile square.
You couldn't do that. You couldn't do that over 100 feet.
I could do it over a mile.
I agree with that. You couldn't do over 100 feet though.
So you agree now that any instrument I could make a horizontal and make a 8-inch drop over a mile?
Yeah. What would you use?
You agree with that?
You
What would
pick.
you use?
Means we
I
should
would
be able
use-
to measure curved earth or curved water easily. And that's what he was asking.
with-
You have
yeah,
a
with-
method to do that.
with GPS. Agreed.
But you can't confirm what GPS is really doing on the other side. So that's why.
Okay. But that's what a lot of modern moving equipment uses.
Yeah, I know, but there can be.
I understand your point, Gio. He was just saying something different than what you're saying, but I agree with you.
No, I wasn't. Me and Gio agree. It would be easy. I've said it for years. This is easy. This is not hard. I do it. I'm dumb, right? I am the most ignorant person here. Yet I do this every day. I establish horizontal.
What was your contention then? Restate your argument that Gio agrees with.
That if this is so easy and if the instrument used is in chat right now, that there would be multiple videos of Globers rubbing it in our face for the last 10 years. Yet there's not one.
That's a great claim. I don't agree with it, but that's a good claim.
I don't care if you agree or not. I think the audience hears the implication.
No, but I was surprised also you agreed that Raqia could make, or that you can make an 8-inch per mile squared gradient. Because if you can do that, then it means that you can measure to the accuracy of what would be needed with these tools.
Yeah, with GPS. Yeah, 100%.
No, but I thought we were talking about.
I don't need GPS to do it. I could use it. You could pick the tool, and I can make that gradient.
What does your total station use?
What are you talking about? It uses GPS.
Easy.
I don't
even understand. Like, okay, whatever.
I do understand. You don't understand that.
No,
GPS
Gio doesn't want
satellite.
Gio doesn't want you to use GPS in what we're talking about, but you are using it, and I agree with you using it.
I don't use total stations every day. I mean, we don't take out.
I'm not saying that you don't.
But I'm saying we could do it with anything. We could do it with a laser. We could do it with a theodolite. We could do it with anything. It's easy. Like, it's not even hard.
Okay, but the fact that you agreed with me that the best way would probably be a total station that uses GPS.
The most accurate way, I would agree with. You don't need to be that accurate to
we're-
make an 8-inch. If you're 8 inches per mile square and you're a quarter off over a mile, that's still accurate, sir. And oh, by the way, that inaccuracy is not always going to be below the horizontal. Sometimes it would be above the horizontal.
Yep, I agree. You wouldn't know which way it is.
Yes, you would. You can measure
How?
it.
How? You
You're
wouldn't be
using
able to.
the tools to measure it, dude. If you're
No,
doing it over water,
it has a
hello,
tolerance of plus or
hello,
minus that.
hello,
Therefore, you can't use it because you can't measure
hello.
anything within that tolerance.
We're talking about errors. So if you're creating a horizontal over static water and you start 1 foot above the water, and when you get 1 mile away, you're 11 3/4 inches above the water, your error is a 1/4 inch above the horizontal.
What word are you using? Sorry, I didn't hear you.
Error margin.
ERROR?
Oh, okay.
Error? Sorry, it sounded like you were using a different word. I'm being honest
Hey,
here.
piss off on your mocking and scoffing, all right?
No, I'm not. Okay,
Yeah.
error
Error
margin.
margin.
Yeah. Do you? But that's why I asked you at the beginning if you knew what your error margin was on your device.
That's why I'm asking you, do you understand that if it's above the horizontal, it's not earth curve? It's just an error margin due to tool or human error?
I know, but how do you know? How do you know if it's within the error margin?
Because you measure it.
You
The whole
cannot
point.
measure something within an error margin. Do you
You
realize
can
this?
measure a 1/4 inch when the accumulative error margins, and in your case, the squared accumulative, which is ridiculous because it's plus or minus. But anyway, the cumulative error over a mile is a 1/4 inch. It's because you can measure a 1/4 inch. What do you laugh? Every time you laugh, it's because you're stuck. That's your tell.
No, you. It's obvious you've never engineered a tool, a measuring tool before. It's fine.
It's obvious that I do this for a living, bro. I can post
Yes,
video.
you use
I
the
did it
tool.
this morning.
You don't understand how the tool is made
Truck
and how
driver.
they determine the error margin. It's okay.
Sure I do.
It's fine.
I can measure the error margin, especially as it accumulates.
With
But it's
you
always
have to hold on a second. I agree you can do that, but then you have to have a more precise tool to measure it.
let me ask you this. You make a horizontal line 100 feet over, and you start 1 foot above the water, and after 100 feet, you're 1 inch, you're 11 inches above the water.
Is the water flat?
What's your Yeah, let's just assume water's flat. Whatever someone's made the most flat thing ever, and you do a measurement, you make a horizontal plane above it, 1 foot. You start 12 inches, you know it's 12 inches, and you go 100 feet, and it's 11 inches. What's your error margin?
You don't know. You don't do that with your
Audience, please listen. Your
Are you
error
saying?
margin is 1 inch.
Sorry. Are you saying that both things are supposed to be horizontal?
You're just fumbling now, bro.
No, I'm asking you because I didn't understand you at first. Are you saying that both pieces are completely horizontal?
Let's just assume you can make a horizontal, right? Let's just assume that. You don't believe that. But someone makes a horizontal plane. Then I come around and make a 100-foot line, 1 foot, 12 inches. You know there's 12 inches in a foot, right? Now I'm mocking you. 12 inches above that known horizontal plane. And when I get to the other end, it's only 11 inches. What's my error margin?
How did you make that horizontal line?
Doesn't matter. I made it wrong. I made it using a theodolite, but I used it wrong. I used GPS, but I didn't set it up right, or it wasn't calibrated right, and it's 1 inch low. What's my error margin?
So that line is 1 inch out of tolerance over a mile.
Bro, the way y'all try and scramble out of an easy answer is amazing,
You
bro.
think they make one measurement to determine error margin? Is that what you're saying?
It's not my point. I was just trying to prove what an error margin is, and you're just fumbling, bro.
That's not an error margin. It's
That's
off
not.
by.
What is it? What is it?
it's off by a inch, but that doesn't mean that's the error margin of the instrument you're using. You
I
know
didn't
that,
say it
right?
was instrument error. I didn't say it was instrument error, but
Oh,
isn't
the
an
line
error?
is off by an inch. Yeah, sure. The line is off by an inch, but that's not error
Is that an
margin.
error? Is that an
It's not.
error?
It is an error. It's not an error margin.
What? It's an error, but not an error margin?
Did I stutter?
No, you didn't. You said it very clear.
Okay.
I'll repeat it. This guy said that 1 inch error is not an error margin in surveying. It's just an error.
Correct. 100%.
Yeah. Okay.
That's
cool.
right.
You got it.
All
Good
right.
job,
Awesome.
Raqia. You learned something.
Yeah, I'm you're just going by a script. You sound dumb, bro.
I'm not going by any script. This is what I've learned in engineering for
Yeah,
25
you
years.
learned. You learned something, Raqia. Yeah, you learned. As you told me what an error was, you learned something as I laughed at you.
Yeah, you
The
know
one
now
inch,
that an
the
error
1
and
inch
an error margin.
differential
Hold
from a
on a second.
non-horizontal
Hold
is
on a
not an
second. You're
error margin.
spurting
It's
out.
just
You're
an error.
spurting out. You just learned
Not
that
really.
an error. Hold on. You just learned that an error is not the same as an error margin.
Yeah, error is not error margin. That's pretty simple.
Yep.
The 1 inch would just be an error.
You got it.
Awesome.
Would you say then if you've made a measurement and it's within the error bars, you haven't made an error?
Oh, there's always going to be errors. It's just they might have equalized out.
So when you make a measurement and it's within the error bars, what you have done, probably the best way to describe it is you have failed to show that the previous measurements were themselves wrong, right? I mean, what you need to do when you test a scientific theory, you make measurements over and over and over again, and you hope, if you're trying to disprove it, which is what all scientists hope to do, you hope that your measurements will be outside of the error margin of the theoretical value that the theory you're trying to disprove predicts. There will
So are
be
we
a,
all in agreement that we can take a GPS and make a horizontal line within the parameters of Earth curve over a mile?
I didn't catch that, sorry.
They're stating that you can take a GPS surveying unit. They even listed a specific model that will establish a horizontal plane accurate enough over a mile that you could measure the whatever drop rate there would be.
Yeah, I don't know over a mile. I think you can do that. You certainly do it when you look at distant mountain peaks like celestial theodolite.
No.
Well, we're talking about the one used for LIGO.
Yeah,
Oh,
we're
I
talking
see.
about
Yeah,
they-
right.
that's what they use
Certainly,
for
yeah,
LIGO.
certainly their precision situation like that, they absolutely do.
So if LIGO was over water and you measured down from the top of the tube, which is perfectly horizontal, let's say, in theory, right, that you would get a drop rate of the water? Be careful.
Yeah.
Okay, so all we have to do is use the same model GPS surveying unit that they used, right? And make a horizontal line 2 meters long, 2 miles long, whatever it is, 2.5 miles, and measure the drop rate. Easy. Why didn't
Well, I
So,
don't
y'all
think
yeah,
it
tell us
works
that-
over
that's a
water.
good-
I don't think it has wheels on it.
Why
Well, I
didn't y'all
like the
tell us?
idea setting up. Suppose you set up a trough of water, right? That you brought up to the level of the middle of the LIGO tube, right? And then you could see whether when the middle of that trough, that water trough, was just touching the middle of the LIGO tube, whether it continues to touch all the way to the ends or whether the ends drop down below that. Pretty confident you'd see that they do.
The ends wouldn't drop below. The ends would rise above.
No, the middle would be higher than the ends. 100%.
Well, Raqia, we can get this done tomorrow. We get this
I'm
done.
sorry,
by
I'm
morning.
saying the floor would
Why
be
didn't
raised.
they tell us this 10 years ago? This is too easy.
Yeah, we'll have it done by morning. All right.
Everything rolls to the middle. You could just pour water on it and watch it go from the ends all the way to the middle.
And then bulge up in the middle. Yep.
They're saying
Yeah.
everything yesterday. Jeremy was hitting them with the stovetop, being precisioned like LIGO, and being like, that should happen on all surfaces that are like, raised up on the four corners to even elevation. All flat surfaces should do that.
You wouldn't
Well,
even
I
have to
like
make
this.
the
This is a good
trough
experiment.
accurate. You wouldn't even have to make a trough accurate. You just have to fill it with water. And it would be higher in the middle than on the ends. That's crazy, bro.
No, I think this is I mean, I don't think you'd get them. I don't think you would very likely be able to talk them into it. They'd probably say, look, if you want to know the shape of the earth, go take a picture of it from space. And then you'd say, but space is fake and gay. And then they would say something like, well, then why don't you just like survey the top of that mountain over there and
No,
notice
you want to
that
know
it's
what
200
actually
meters
happened?
lower than it should be.
Yeah, you want to know what actually happened when I talked to the engineer in the house at LIGO in Livingston? He said all you got to do if you want to know that the earth is curved is go to a beach and watch a ship sail away.
Well,
That's
that's true
exactly
too.
what he said.
I
Oh,
actually
that's true
find
too?
that to be, at least where I am on the beach, it's not really satisfactory because, things get, I rarely see clear enough days where I can really see that. And there's mirages and things. And over water, light is really, I mean, that. I mean, the refractive
Yeah,
properties of
yeah,
air
yeah.
over water are
On a clear day,
highly
though, you can see
variable.
that obstruction. On a clear day, and from what you just said, there would be bottom up obstruction. On all the other days that aren't so clear, there might be some other effects, right? Boat in the sky, mirage, boat
Yeah, that's
appearing
right.
underwater, earth curve. Yeah, I got it.
Yeah, those things happen. I mean, but once again, that's
Yeah, I
that's not
agree. They're boat mirages.
the
The
better
boats
the
off,
better
off,
way
boats
the
float on
better
top of
way to
not the sky
to
or under.
determine the better way to determine that the Earth is curved is just to notice that horizons. One of the things that you'll find is that if you go to the beach on a clear day, the horizon is really sharp. You look out there and the horizon is incredibly sharp. You'll never see that from a mountain top or from a plane. If you look at the horizon, whenever the horizon is more than 20 or 30 miles away, it's never sharp because atmospheric extinction and haze and all sorts of things start to come into place. On a flat Earth, the horizon is thousands of miles away. So on a flat Earth, you can't even see the horizon. It's buried in haze. You see ground, and as you look toward the horizon, it becomes haze. And then as you look further up, you finally start seeing sky. But the fact of the matter is that on the Earth, the horizon is incredibly sharp when you're standing right on the seashore. And that's because it's incredibly close.
I'm really convinced of this. How did you calculate the flat Earth? Like, I'm a 6 foot tall man. How far is my horizon on the flat Earth?
Well, thousands of miles. Well, I mean, is it an infinite flat Earth or is it a 12,000 mile diameter flat
No,
Earth?
I'm asking how far the horizon, the apparent position where the sky meets the ground, the flat
Okay.
plane, how far
Well, then
away
let
from
me
that?
then let me answer. Since you won't answer the question, I will take the example of an infinite flat Earth. On an infinite flat Earth, the horizon is infinitely far away.
Where the sky meets the ground for a 6 foot observer, you could say on a flat plane that's infinite, it would be infinite away.
Yep.
Holy shit, man! I never heard that before.
Well, it's pretty simple geometry. Look, the thing is when you, on a flat Earth, on an infinite flat Earth, assuming no refraction, assuming no atmospheric haze, just for a moment, if you look down at your feet, you're looking at the ground. You look a little further up, you're looking at ground. You look a little further up, you're looking at ground. In fact, you're always looking at ground until you look out exactly horizontally. Because if you're looking downward at
I agree.
all, you're looking at the ground. And that's because all the way out to infinity, there's ground, below your feet. So, so when you're looking directly out horizontally where the horizon is, you are looking at the infinite final point of that plane. Right? There's nothing on that plane that is blocked from your view. You may not see it because it might not be bright enough. But if you took a laser and took that and have a laser right on the ground and you moved, it's pointing toward you, but it's right on the ground, you move it further and further and further away, you will continue to see it until it gets too dim to see. It'll never be a point where the light is blocked from your view. So you will, if it's bright enough and nothing's blocking your view, you'll see it. That's pretty grade school optics.
So on a curved spherical Earth, the horizon, you just see sky, right? You don't see the ground? Because
On a curved Earth, that's right. I mean, once again, neglecting refractive effects, neglecting atmospheric haze. If you're standing 6 feet above a level surface, the ocean, the horizon will be 3 miles away, and it'll be sharp.
How would the horizon be 3 miles away if the ground, you're above the ground 6 feet and it's curving away from you as it goes 3 miles? How would the ground ever be at your eye level?
It never is. On a globe, there's always the thing we call horizon dip. If you're 6 feet tall, the horizon dips by about 2 arc minutes below eye level.
What makes it appear that the ground rises up towards your eye level with a little dip, and that point where the sky meets that apparent position of the ground that's appeared to rise up is your horizon on a sphere? What's that called?
I'm not sure what you mean. The horizon is the horizon. If you're talking about why does it appear to be at eye level,
of where you see the ground meet the sky, where you see it. It's not actually where the ground is, because the ground is 6 feet below your feet. You would never see the ground rise towards your eye level if it was curving away from you, unless it was an apparent position caused by your vision. Hang on, I'm going to finish this for the audience.
Okay.
I'm going to finish it.
Right. Okay.
Caused by the conditions of how we see. So whether you're on a spherical, actually on the sphere Earth, it's worse because the ground's curving away from you. So it would be it would never happen. Actually, I don't think. But on a plane, it would happen at the same distance at least as on a sphere Earth. Like it wouldn't be any different because it's an apparent condition of how we see it. Yeah, I know you can formulate it and theoretical physics the shit out of it. You sound very convinced. But I think the audience understands now that if you're 6 feet above the ground on a sphere, 3 miles away, that ground is no longer 6 feet below you. It's 6 feet plus the drop rate over 3 miles, which would be what?
That's right.
8 feet, 9 feet, or whatever it is, 12 feet,
Something.
30.
I think 12 feet. Yeah. Is it 12?
So 12 feet plus 6, 18 feet below you. But it appears to be rising towards your eye level because of an optical phenomenon, right? So you're saying that same optical phenomenon wouldn't happen on a flat plane? This is too easy, bro.
So I don't know. I mean, you're saying it appears to rise toward eye level. You may think it does, but it doesn't. You can measure it and you can see. You can take a theodolite 6 feet above a level surface, the water, and you can easily measure that the horizon is about 2 arc minutes below eye level. That's easy for a surveyor to do.
About 18 feet and 3 miles. 6 feet observer or theodolite height and 12 feet of drop. Right?
Yeah, the horizon is 12 feet below your eye level. That's right, and the angle that it makes, the angle that point in your visual space makes with eye level is 2 arc minutes.
That sounds cool, man. Y'all are really into this. I like it. So the horizon, just to conclude, right? We don't want to beat this to death because it's been 10 years of talking about how the horizon does or does not rise to the eye level. No one, and I mean nobody, ever says that it doesn't appear to rise towards your eye level.
Well, I just did. I mean, well, okay, no, you're right. I mean, I do agree with you that there's a strong psychological urge to when you see the horizon to say, oh, that's eye level, right? That's a strong psychological thing. But that's why we have instruments, and instruments can show you that it's not.
Yeah, but it does appear when your vision, right, when you're looking at when you're going to the beach, as you stated, and you're looking at the horizon with your eyes and your brain is interpreting what you're seeing, under normal conditions, that horizon that's 3 miles away appears to rise towards your eye level, correct?
Well, I'm not sure what you mean by appears to rise. Here's what I think when people talk about appearing to rise, I think they say that when you go up, if you were to go up in a balloon, it would look like the horizon is rising. And in some sense, it is with you. But if you, as you get higher and higher in the balloon, if you simply measure it, you'll find that it drops very quickly, significantly below eye level. You can take, there's a thing called the theodolite app that you can take on your phone. I've used it myself on an airplane and see that the horizon drops by 6 times the diameter of the moon from an altitude of 35,000 feet. That's a very significant horizon. And you can just hold a Coke bottle up or a water bottle against the mirror, against the window. That'll make a level surface, a locally level surface, a locally horizontal surface. And you can just see that the horizon is significantly below the level of that water in that bottle. That's eye level. It's below horizontal, below local horizontal.
Yet it appears to rise towards your eye level, correct?
Yeah, I get
in
that.
an airplane, balloon. Okay, yeah, that was yes. You agreed with me. So on a flat plane, would it appear to rise towards your eye level?
Yeah, on a flat plane, it does rise
Thank you.
to your eye
I'm
level.
done with this guy. Anybody else? When you get the answer you're looking for, just move on. So it wouldn't be infinite distance if we could see so far. The horizon wouldn't be infinite far away on an infinite plane. It would appear to rise towards your eye level. Thank you.
No,
Very
no,
good.
on a
You've been
flat
so
plane,
good.
it does rise to your eye level. The fact that the horizon does not rise to your eye level is one of the reasons we know that the Earth isn't flat.
So on a flat plane, it does rise to your eye level, which is just an apparent position, right?
Well,
It's
everything is
how we see
apparent.
over
The
here.
only thing we can see are
Yeah.
apparent
If you're
things.
6 feet above the plane and your eyeballs create a horizontal line infinitely away, that horizontal would be, say it for me, 6 foot, right? 6 foot?
With
6 foot
infinitely far.
above the plane, although the land would appear to rise to your eye level, it's not. It's actually 6 foot below you, right? Just
No,
agree
it
with me
doesn't.
again.
No, I get that you might think it feels like
No,
it's at eye
don't
level,
try.
but you can measure it and
It's
see
over,
that it
bro.
doesn't.
It's over, bro. Over. What you can measure is that when you are 6 foot above the water and you measure out to the water, creating a horizontal line out and measure down to the water, when you've done that accurately, the horizontal line is still 6 foot above the water. That's
No,
what you can do. Yeah, in
no, you
reality.
can't do that.
Yes, you can. And in
Okay, well then
reality,
do it.
when you observe the horizon, even on a sphere, it appears to rise. This dropping Earth appears to rise up towards your eye level.
I get
Amazing.
that,
confused
but
about
I
the
get that it appears
geometry.
to, but
He's
all
getting
I'm
confused
saying
about
is
the
that it
geometry of it.
doesn't. The important thing is, does it rise to eye level? And the answer to that is no. It's easy to measure it, and when you measure it, you find out that it doesn't.
He said rising. He said rising. Sorry, he said rising towards eye level. He didn't say two. He didn't say two that I heard.
Yeah. And I agree. When you measure it, when you're 6 foot above the plane and you measure it, the horizontal line that you created is still 6 foot above it. Yeah, I agree with you.
So flat earthers used to always say that the horizon rises to eye level. And there's good reason for that, because on a flat earth, the horizon does rise to eye level. In fact, if you take in refraction into account, it rises to above eye level. The horizon on a flat earth would in fact be above eye level. But the horizon on the Earth is below eye level, and it gets more and more below eye level.
Because of optical
the higher
illusions.
you go.
Yeah, I agree with that, because you're looking over a longer distance and you don't know what the true horizon is. Yeah, I agree. It's an apparent position, and that apparent position changes. Most of the time it's low, but you know what? Sometimes it's higher. Even Globers have posted the horizon higher than the horizontal.
That's right. Jesse's taken some
Yeah,
measurements
both
like that.
Jesse Kozlowski, two Jessies now. Isn't that ironic? Have done it. Kozlowski and Path of Light. Yep,
Yeah,
I
Jesse
did it.
Jesse has a video, I think, a situation where the atmospheric refraction was such that it raised the horizon so much. It always raises the horizon, but it doesn't usually raise it above eye level.
Yeah. Sometimes it only raises it below eye level. Yeah, I agree with you, man. You're right on. Congratulations. Yeah,
Thank you.
optical long distance observations are not what you should use. You should actually use the shorter, more accurate measurements. And when you do that, it's not curving ever.
Well, I know you believe that.
No, I know it. I've measured it.
Well,
And
the,
now
the
that I
problem
know,
the problem is that the horizon is below eye level, and that cannot happen on a flat Earth. Under very unusual situations, you might find that on a flat Earth. But the fact of the matter is that
can or
it's the
can't?
other way around.
I
You'd have to
misunderstood.
have sinking refraction. You'd have to have seriously sinking refraction for that to happen on a flat
Serious
Earth.
sinking reflection?
There is, but it's not usual. You'd have to have it all the time.
So let me conclude. He said that we do have conditions called sinking refraction where on the flat earth, which is where we live, that it happens right now, today, tomorrow. It's happening somewhere right now.
Not in
I agree
Vegas.
with it.
Not in
I agree
Vegas.
with you again. Yeah, I
Maybe
agree
you
with
live on
him.
flat Earth, but I don't.
Well, you might not. You might be in a different realm. I can't prove that. But I can tell you where I live right now, the water that I'm around is not curving.
You don't understand
Congratulations.
scale. You don't understand scale, dude.
So now it's on me, right? I'm dumb. Maybe I do.
Exactly.
Yeah.
Your words.
Exactly.
Your words. Your words.
I got you. You got me. Yep. I hear
Not
you.
dumb, just comprehension problems.
Right. I got the problem. I understand. Or it's not me. Or that. And don't forget, I was a glober once, right? When I did these measurements, I was a glober. It's because of it's because of
I
the
love that
measurements
story.
that made me not be a glober.
Yeah. So I'd return once again to the simple fact that when and only when you're standing a short distance above a level surface, you see on a clear day, you'll see a very sharp horizon. And that sharpness is a clear indication that it's close, because horizons that are even 20 miles away are virtually never sharp. You start to get atmospheric extinction, and horizons that are thousands of miles away can't even be seen. So the fact that you can see the horizon already tells you that it's Earth, a globe Earth. The fact that it's sharp it seals the deal on that, because you can never have a nearby horizon on a level surface on a flat Earth. That's impossible.